Okay, come on up here and explain to us what you're doing. And then you can pick somebody else from the audience to go next. Perfect timing. You just came in time to volunteer. What time we're supposed to start? I find that line in the middle is horrible. The conference room should be open right now, so maybe we should move to the conference room. What are you doing?
Wait, I'm supposed to.
Where did the 8 come from?
From the.
You don't put
Is it-
that in until the very end.
Oh, so
First, have to
should
use
I?
that limit formula with x plus h and x and equals 0. First, use it for that function, and then when you simplify it, whatever's left, then you plug in 8 as an answer. That's a input.
So I would first I have to plug this in.
Yes.
To
First, you have to
here.
do that right.
Okay.
Instead of 8, cut up the 8, put an x there in place.
I know there's a certain. It's supposed
In
to.
the first one, you have x plus h squared.
You're right.
FOIL.
Yeah, I know there's like a formula I'm supposed to remember, but I can never.
On the type, just use the old algebra.
Yeah.
It's pretty. There is a formula, but yeah, we'll go on that. It was parentheses. If we can't do anything as long as we have a parentheses. So we put it in parentheses. And that's the formula. It's the first term squared. In this case, it's plus 2 times the first and the last term, plus the last term squared.
Yeah.
That's the formula. Yeah, you get it. And the rule of thumb here is whatever's after that minus sign in that f of x, a plus h minus f of x, whatever that minus f of x part has to cancel with something on the left hand side, right?
Yeah. So these two.
So yeah, so that's a good sign. If it doesn't cancel, then we did something wrong.
And then I would then have to cancel out the h's.
So factor them out first. Factor it out on top first.
Wait, say that again. Sorry. You said what? What did you say?
Factor out the h. How many h's can you factor out on the top?
Oh, well, one each.
Only one h. So
one.
factor out one h out of the top.
I just get rid of that.
No, see, you can't do that. That's what I want you to do. I want you to factor it out first.
Oh no, I know what you're saying. Okay. You're saying like multiply the top by h.
H, O times parentheses, right?
Yeah. Right there.
Just look at the screen behind you. That's what we're seeing. So just move it. Okay, now what you took out the H, right? But you took out when you factor out the H, because if you distribute now, will you get the same thing on the left side? Will you get if you take that H and times 2xh plus h squared, if you multiply those, will you get the left side? Let me show you. When you factor something out, you took out the H. So now you took out H right here. So inside here, you took out one H, so that H is gone. It's right there. And you took out one of these H's, so that 2 is gone. Because now if I multiply this to these, I have to equal this.
Yeah.
So H times H is not going to be H. It's going to be H squared. So it's going to be 2x, right? Because we took out the H. So basically, when you factor it out, when you take it out, what's really happening when you factor something out, divide both of these by H. And that's what goes here inside the parentheses. Whenever you factor something out. So if you take 2xh divided by h, what do you have left?
You have 2x.
Yeah, so that h is gone. So if you have h squared divided by h, you have
H.
So that squared is gone. Right, so that's what you have now. Now can you cancel anything top and bottom?
Would you cancel out these two h's?
Yep. Right, that's the reason why you factored it out. And I'm glad you're putting the limit. Always put that limit in front, because it's still a limit until we take it to go to 0. Very good. Okay, now what do you do?
How do we so we plug in there 0?
You haven't taken the limit yet. Oh, yeah. You said put 0. Yeah.
Yeah.
Now we take the limit. So we put, yeah. So h goes to 0, leaves us with what? Leaves us with? Not limit. We're done with the limit.
Oh yeah.
Once you take it and go to 0, it just leaves whatever's left.
Equal to x.
Okay, so that's your formula. Now, what is x going to equal?
8.
Okay, now we put it inside there. So that's your limit value. How could we have checked it from the beginning?
Take the derivative.
Hey, derivative of x squared is
2x.
yeah, and then plug in 8 for x. Would have got 16. So yep. The answer is 16. Follow that? Right up. Yeah, now it says the h goes to 0. Anywhere we see h, we put a 0 in its place. So at this year's, all we have left is 2x. Yeah, the value of x is 8. Go ahead and forward it up there.
Can we check it? Okay, that wasn't there before, was it?
Yeah, it's already there.
Oh, it was.
I might know what I'm doing. Okay, this is epsilon delta. Remember how to do these? Anybody remember how to do these? This. I'll do this.
Yeah, I think we stopped here.
You got picked for the wrong one.
All right. It's asking for, it's number 11. So, well, they give the function f. And given value c, epsilon is greater than 0. Find the limit as x approaches c of fx. Then, yeah, I have to write the question down first. Then determine largest value for delta greater than 0, such that 0 less than x minus c is less than delta implies absolute value f of x minus L is less than epsilon. B is equal to 3, epsilon equals 0.1. This is the important part right here. That's what we have to prove. So what we have to do is we have to plug in what we know. And we're saying that epsilon is going to be 0.01 or 0.1. So what we're looking for here is this. Well, if we plug in 3 inside this equation, what do we get? We get 0 over 0. What does that tell us? It means that they have something, they have to have something in common if they both go to 0. So the top number, x squared minus 9, this is already as far as it goes. We can factor the top. It's x squared. 9 is made up of 3 squared. So we have a difference of 2 squares. The difference of 2 squares, so it's x minus 3 and x plus 3. Follow that? Okay, there's a formula in algebra. It's the difference. If we have 2 terms that are squared with a minus sign between it, it can be factored out by taking the 2 terms, making 1 plus and 1 minus in the middle. That's called the difference of 2 squares. This is the first one squared and the second one squared. So in our example, we had x squared minus 9 squared. Well, 9 is 3 times 3. So it's x squared minus 3 squared. So that's my A and that's my B from here. So I have A plus B, A minus B. So it's x plus 3, x minus 3. Then these can cancel. So my function is now just x plus 3. The reason we're using c equals 3 is because c is our critical value. It's the only number that makes this equation blow up. If we used anything else, it wouldn't matter. It would work. The only number we can't use here is 3 because it makes it 0 over 0. So that's why we're evaluating it. So now here's our function, f of x. We have to solve all this stuff up here. So we have 0 is less than absolute value of x minus c is less than delta, implies the absolute value of f of x minus L is less than epsilon. So what can we plug into here? What do we have defined? X is a variable, has to stay X. Do we know what C is? Yeah, so we have X minus 3. Yeah, of course, you have to ask. This is college. Make yourself at home. What's f of x? X plus 3. What's L? L is the limit. Right here. See, L is the limit of our function. Oops. L is the limit of our function as x goes to c. So in our case, the limit of x plus 3 as x approaches 3. So if we plug in 3 here, 3 plus 3 is 6. That is what our L is. Because the first time we tried it, we got 0 over 0. So once we fixed it up, now it works. We have an L. So and our epsilon was defined as 0.1. So on the left side, we can't do anything just yet. Three minus 6 is minus 3. So far, so good. Since we have these are the same, and this value has to be less than 0.01, that tells us that delta has to be, it should be 0.01 has to be less than delta. So the largest delta can be, the largest it can be is 0.01. And that's our answer. Because since these two parts are equal, that means that's what our delta equals. Because it is greater than 0, true. So in order for these two to be equal, delta, this function has to be equal to that. That's the largest it can be. Anything else smaller than that is still, it's optimal. So that's what that one's asking. And these again are like pulling teeth. It's just like they go on forever. But once you get these two absolute values to be the same, then just compare the epsilon and delta values. All right, can I move on? Number 12. Give the epsilon delta proof for the limit fact. Okay, let's see what this equals. This is for number 12. Epsilon delta proof for the limit as x approaches 0, 9x minus 2 is equal to -2. That epsilon be greater than 0 be given. Yeah, that has to be. So what does all this stuff tell us? What are all these? Remember, the epsilon delta proof. That's the one we just did. That's the one that looks like this. That's the epsilon delta proof. It is, because this has to do with the x values. What that's saying is, as your x, well, the limit as x approaches c of f of x is equal to L. So as our x value gets closer to c, our function approaches a limit. So these have to deal with the x values. As the distance between your x value and your c value, as they get close to 0, infinitely close to 0, the function approaches a limit value. There's if this is c and this was L, and that's our point on our curve. Then as these are my x's, as they get closer to c, the distance approaches 0. So our delta approaches 0. That's what that says. As it approaches 0, that means these points are getting very, very, very close. These x values of our graph are getting very close to that x value. When that happens, that means the y values, the corresponding y values, are getting closer and closer and closer to the limit value. And that's what this one tells us. Each one of these f of x's, remember, f of x is the same thing as y. Each of these y's are getting closer and closer and closer to our L. That means the smaller this becomes, it becomes 0. Epsilon is greater than 0. True, because it has to have a distance between it. But as that distance goes to 0, it becomes infinitely small. So what can we define on all of these? X has to stay there. What is C? Look at this equation up here, the formula. X approaches C. So that is what C is. This implies f of x, that's our function, 9x minus 2. It approaches some value, that's my L. This becomes a positive. -2 plus 2 is just 9. That goes 0. Are these two equal? No, but how can we make them equal? 9's a constant. It's positive 9. So I could bring it out in front. So delta equals epsilon. When absolute value of x over 9. If absolute value of x equals 9x, that means absolute value of this side, the delta over 9 is equal to epsilon. Because right now it's absolute value of x here is 9 absolute value of x here. In order for them to be equal, I have to divide both sides by 9. I get this. All right. So out of all these, let's see which one looks like what we had. All of them have x minus 0 less than delta. Implies 9x minus 2, 9x minus 2, minus -2. That's good. So delta over 9 equals x. So it has to be a. Because that's what our formula was. That's the only way that delta and epsilon are equal. How about this one? We know that a given proof from Cal 1 that says if the limit of the theta as theta goes to 0 of sine theta over theta goes to 1. We proved that by the squeeze theorem. Find the limit as t goes to 0 of sine kt over t. K is a constant. So this is what's given. This is our squeeze theorem of, in general, as theta goes to 0, sine theta over theta, or sine t over t, as it goes to 0, is always equal to 1. So how do we make this equation look like this? How many of y'all get this right if I had this on a test right now? If I told y'all close your books and everything, I gave something similar to this, how many of y'all get it right? Remember, this is calculus 2. This is getting you ready for the calculus 3. If you guys are in these courses, that means you want to be engineers or some scientific. You have to know this stuff. If you don't know it, you should be asking questions. Because you're lucky that I'm very patient and everything like that. You'll after these courses, you'll transfer to university where they're going to have about 80 students in the classroom and they won't care. And they're going to give you one test, one exam, and that's it. Very good. We can factor out the K, not the T. So this, as T goes to 0, becomes 1. Our answer is K. Yeah, but since it's a constant, once we put it out of the trig function, because it's simply a constant. The sine of 4 theta is the same thing as 4 sine theta. Since that's a constant in front of here, the limit doesn't affect it. So I take it out in front. We have another one. Yeah. Okay. Same thing. Limit theta goes to 0. Sine theta over theta is 1. That's given. Find the limit of y goes to 0 of sine 14y over 11y. What's the answer? Yeah, so here. Fourteen over 11 is a constant. This goes to 1. And there's your answer. I mean, this right here. Yeah. It's gonna be the same. You can change it to whatever you want to. It could be Y, it could be T. It's just that whatever this is has to be in the equation. Sign something over something. That always equals 1. Then how do you think you're gonna go about doing this one now? How are we gonna factor this one? Because remember, we have to try to get it sign on top, no sign on the bottom, which means there's a sign down here already. We know this 20 can come out in front. So how do we get rid of the sign on the bottom? How do we go about that? What rules do we know? Of what? The top or the bottom? Let's try that. Let's start with the reciprocal, not the reciprocal, but the conjugate. Let's multiply by so what's that going to give us? One or a minus b, a plus b. That's the same thing as a squared minus b squared. One times one is 1. positive cosine minus cosine 0, negative cosine times positive cosine is negative cosine squared. What else can you do? Right. This is one of the identities. Sine squared plus cosine squared equals 1. So sine squared equals 1 minus cosine squared. So that top becomes sine squared theta. And 20 sine theta, 1 plus cosine theta. Actually, I've got a lot of things that said I'm gonna make copies for y'all or send it to y'all. These guys. There'll be something. I'm gonna send you something like this. There's all the trig identities and trig formulas. Look at this one. Sine 2x, a double angle, equals 2 sine x cosine x. This is a double angle of sine 20x is sine 2 times 10x. Which is 2 negative sine x, or 2 sine 10x cosine 10x. We could have done that from the beginning. That would have helped. Go on. So what you want from there? I'm gonna use x's instead of thetas. N can come out, get a 20, so it's sine x. So sine x and since it's no longer 0/0, cosines when x goes to 0, cosine of 0 is 1. Cosine of 0 is 1. So 1 plus 1 is 2 times 1 times 20 is 40. Sine of 0 is 0. 0 over 40 is 0. So it's a valid answer. Again, this just comes of just looking at your trig identities and just seeing which one will work for you. Since this one is 2 times 10, this is a double angle of, this is my angle 10x. Find the slope of the, okay, this one's going to be pretty quick and easy. Anybody venture to guess what the answer is? What's that? 12. Because the slope of this curve is 6x. The x value is 2. So the slope of the curve at that point is 12. 12 over 1. Let me put down. No, because when you're looking for the slope of a curve, you want it at the x value, which is 2, and that's 12, but that's all we need. That's my input. If we took 2, plugged in the original equation, 2 squared is 4, 4 times 3 is 12, yes. So now at that point, the slope is 6x. What is x? X is still 2. Find the derivative of that one. We just have to find the derivative. What rule we're gonna use? I used X instead of T's. What rule we're gonna use? Quotient rule. It's also, well, we're gonna do some other stuff inside the quotient rule. So let's see this. We call the top F and the bottom G. So F is 8x² minus 6. The bottom G is 5x² plus x minus 9. Then we have to find the derivatives of those. The derivative of 8x² is 16x. 10x plus 1. Because the way I teach the quotient rule and the product rule, all these sorts of things, I use this format. F and G, F prime, G prime. Since this is a quotient, the bottom number, G, is squared. The top number, start from G, multiply by F prime, and subtract by the FG prime. So what you're gonna do is G F prime minus FG prime over G squared. That's the quotient rule. So we have 16x times 5x² plus x minus 9 minus 8x² minus 6 times 10x plus 1. Because this is f prime times g minus f times g prime, which is what the formula says to do. Now we just multiply these two together, just combine them and see if we can simplify it. 16 times 5 is 80. X times x² is x cubed. Plus 16x². Minus 144x. 9 times 6 is 54. Carry the 5. 9 times 1 is 9, plus 5 is 14. Eight x squared times 10x is 80x cubed plus 8x squared minus 60x minus 6. We can't combine any like terms inside there, so we have to distribute that negative sign. Which will give us 80 x cubed, 16 x squared, 144x minus 80 x cubed minus 8 x squared plus 60x plus 6. This is just algebra from here. There's no more calculus. It's just once we got this done, plugged them in there, we distributed, FOILed these, simplify if we can, then get rid of the brackets. There's nothing in front of this one, so I just dropped the parentheses. This negative changes the signs of everything inside there. Now I combine like terms. Eighty x cubed, 80x cubed, positive, negative cancel. 16x squared minus 8x squared is 8x squared. Negative 144 plus 60 is negative 84 x plus 6. We could factor out a 2 off the top. Get 4x squared minus 42x plus 3. And that doesn't take us any further. As far as we can take it. That's the derivative. Nothing simplifies. Find the derivative of the function. Now we use what rule? We use a product rule, right? I use like x's instead of t, so I'm putting x's. All right. This is the product rule. So in this case, it's F times G. This is F and this is G. One minus X. G is 1 plus X squared -1. We have to find the derivatives of those. So the derivative of 1 minus x squared is -1. Because the constant goes away, x goes to 1, so it's -1. Now we have this quotient rule, not a quotient, but the chain rule. We have to take the derivative of the outside first. Subtract 1 makes it -2. Times the derivative of the inside, which is 2x. Take the derivative of the outside, leave the inside alone, times the derivative of the outside the inside, which becomes -2x, 1 plus x squared to the power -2. The product rule is the same fishy thing, but this time we add g times f prime plus f times g prime. So 1 plus x squared to the power -1, that's g, times -1, plus 1 minus x times this, -2x, 1 plus x squared to the power -2. What do negative exponents mean? Well, it means it goes on the bottom. So we have a -1 on top over 1 plus x squared. Plus, this one's on top, 1 minus x times this one, -2x, all over that part. 1 plus x squared squared. Well, I'm sorry. So what do I do now? Can I combine them? Not yet. This one's squared, this one's to the power 1. So I have to multiply this one by 1 plus x squared over 1 plus x squared. What's sad is it's true. It's the hardest part is always the algebra part. So I have a common denominator. I can distribute this one. So it's -1 minus x squared. I can distribute this one. So it's -2x times 1 is -2x. Negative is a positive. 2x squared. I needed to get rid of the parentheses up on top anyway. combine like terms. So I have 2x² minus 1x² is only 1x². Minus 2x minus 1. 1 plus x² squared. Now what? Can we factor this now? What does this one factor out into? If it's minus minus, then this would be a plus. Let me see, did I write it down correctly? Yep, it's 1 minus x. In other words, if it was 1 minus x, 1 minus x, then it would be x² minus 2x plus 1. You're right. That's what I was looking at first, but it didn't work out that way. I was hoping that they were going to cancel, but no. Unless I did something grievously wrong. So let me make sure the equation's correct. One plus x² to the power -1, 1 minus x. -1, -2. Okay. Yeah. That's what I got. That's my derivative. Is there another way we could have done it? Remember the original function. We could have rewritten it. That's what the -1 means. So that means our denominator has to be this squared. That's a good checkpoint. We do the quotient rule. So let's check. So the bottom is right. We just have to check the top by doing the fishy thing. F is 1 minus x. G is 1 plus x². F prime is -1. G prime is 2x. So it's GF prime minus FG prime. -1 times 1 plus x² minus 1 minus x 2x all over the denominator squared. Distribute that. It's -1 minus x². Two x minus 2x². So it's minus 2x plus 2x². Two x minus 1x² is x² minus 2x minus 1. So it's the same things. We know we did it right. Although the quotient rule would have been much easier to do. It only took me a quarter of a page instead of three-quarters of a page. Any questions about this? Notice how I always use the fishy thing. Once you define your function, if it's a product rule, g of x times h of x, then the derivative using this is h times g prime plus g h prime. Quotient rule is it? So it helps if you break it up into pieces. Find the derivative of this one. E to the negative x plus e to the 3x. Find y prime.
The E is the log or the function?
What's that?
E is the log or function?
No, it's the exponential function. No, the derivative would not be the logarithm. Remember, y equals EU. The derivative is EU du. So the derivative of E is always E. You just take the derivative of the exponent and that goes in front. So in other words, if I had e to the 3x, the derivative of 3x is 3, e to 3x. So this always remains in the equation. Only thing changes is the derivative of the exponent in front. So y prime. What's the derivative of e to the negative x? It's going to have an e to the negative x in the final answer. What's the derivative of negative x? Minus 1 times 2. So the 2 is a constant. The derivative of e to the negative x. So it's EU du. The derivative of that is negative 1. So it's 2 times negative 1 e to the negative x. Plus the derivative of 3x is just 3 e to 3x. And here's your derivative. Yeah, the derivative of logs, derivative of log or ln x is 1 over x. Yeah, so but the derivative of exponentials, e's, are just pretty much the derivative of the exponent goes in front times the equation itself.
If in the term of in case of x, there will be like some number or constant number that will be 0. Derivative.
Well, this is what u is. It could be a number, it could be an entire equation. It could be a trigonometric function, like 3 cosine.
There is 1, then it will be 0. Like,
Yes. The
derivative of one is zero, that constant term derivative is zero, or we can do that like
So what you're saying is the derivative of E is zero.
two e to the power minus x in term of x, there will be some constant number like 1, 2, 3. Is it possible to do derivative of that?
Yes, yeah, it would be zero. Because e to the power, e squared is a fixed number. But remember, e is 2.7171817. If I square it, it's a number. The derivative of a number is zero. So yeah, if it doesn't have a variable up here, it's a constant. Yeah, so if that's a very good question. If I had 2e to the power 3 plus e to the 3x. Very good question. The derivative of this is a constant, so it would go to zero. The derivative of 3x is 3. So your derivative would be 3e3x. Yes. Very good question. Okay, can we move on? Find the derivative of this function. So x to the 4th over 4, 5 over 6 x cubed minus x squared plus 4x minus 9. So we have to first find the first 5 derivatives. What's y prime going to be? So since fortunately these are all separated by plus minuses, we do each one separately. The derivative of x to the 4th is 4x cubed over 4. Those 4's cancel. 5, bring down the 3, x squared, the 3 and the 6 cancel. So we get x. I should look where I'm writing so I don't get that bar in there. Plus 5 over 2x squared minus 2x plus 4. So that's y prime. Y second, double prime. 3x squared. Bring the 2 down. So the 2's cancel. So that's my second derivative. Okay, review from calculus 1. What does this one find? What can I do with this? What can you do with the first derivative? It finds the slope. With the slope, I could find where the function is increasing or decreasing. I can find maxima, minima. How do I find maxima, minima? Okay, how do I find if something's increasing, decreasing? Well, let's just say I have a function. I took a derivative and I just pick an x value. How would I know if the function at that value is increasing or decreasing? Has to do with signs, yes. Well, yeah. If it's increasing, the first derivative is positive. If it's decreasing, the first derivative is negative. How about maxima, minima? What does a critical number find? No, actually,
From the, we have to factor the function and from the that function. And the first derivative and that first derivative being a critical number. In that critical number, we have to put in the first function, not in the derivative.
in the original function.
We are in the
Okay, yes. What that's going to find for us, the critical values then, what you're saying are the intercepts. But the critical functions are not found by the derivative. It's found by the original function set equals 0. The critical functions would be, critical values would be found here. What values would make that equal 0? Because then you'd find out where is it across the x-axis. Then you'll find out is your function positive or negative in these domains. But the maxima minima, if the first derivative on one side is greater than 0, and on the other side is less than 0, then we know the maxima and minima are wherever first derivative set equals 0. This equals a vertex. It's either going to be it's either going to be the maximum or a minimum. So if on the left-hand side of this value, if the values are all positive, that means the slope is increasing, and then this side's decreasing, then this is a maximum. If on the other side, these are negative, means a downward slope, and then they're positive, this has to be a minimum. So the maximum minima are determined by the first derivative set equals 0 to find the vertex. What can we do with the second derivative? What does the second derivative find for us? Concavity. Concavity is how it's shaped. It's concave up if the second derivative is positive at that point. It's concave down if the second derivative is negative. What do you call the point when the second derivative is equal to 0? Those are your hints. No cheating. I'll give you a clue. The middle word is of. Nah, it is point, but not intersection. Point of inflection. In other words, whenever a curve does something like this, with the sine and cosine, at one point, it's neither increasing, it's where it stops and starts beginning to go down. This one is where the second derivative is equal to 0. It's the end of the concave up and the beginning of the concave down. Because if we keep on looking at it, this side is going up, this side is going down. So at that point, it's the point of inflection. That's where it's bending. Okay. Yes. Because if you ever went skiing or ice skating or rollerblading, if you're turning, you're pushing on one side. Eventually, at one point, you have to turn your skis or your skates forward, then turn to the other side. That's what's happening here. That's the point of inflection. When you turn your skis or your skates from turning to straight and then turn again. Even your car. If your car goes like this, if you're turning your wheel, and if you have to turn again that way, you have to get to one point where you're going straight, and then you have to turn it again. So you're turning your steering wheel, you're going straight here at this point, and then you're turning left, right. So this is what's happening. Anytime you turn, you change directions over the wheels. Okay, what about the third derivative? What is it going to be? 6x plus 5. It doesn't find us too much. The fourth derivative is 6. And the fifth derivative is what? 0. Right. In physics, in engineering, the second derivative is acceleration. The first derivative is velocity. Yes, on this point here, if you find the second derivative, you can find, since it's parabolic. A parabolic equation looks like this. We know it's opened up because the leading term is 3. It's positive. It opens up. The y-intercept is at -2. We can find the vertex. How can we find the vertex? No, that where it equals 0 is. Yeah, where the slope equals 0, yeah. But the vertex, there's a formula we can find. -b over 2a. And then plug that back in there into the function. -b over 2a. So in our example, we had 3x squared plus 5x minus 2. A is 3, B is 5, C is 2. So -5/6. And then plug this value in place of X. And wherever that point would be, that's your Y value. That tells you. So once you find the X value, plug it inside the function, that tells you the Y value of your vertex. Okay, that was number 20. I'm sorry, I'm eating all your time up. Number 21. Find the derivative of 9/x plus 7 sine x. How do we do this? Yeah, we're doing both separately. Since it's plus, we'll do both of them separately. This first one, we can rewrite it like that. So the derivative, 9's a constant, it just stays there. The derivative of x to the -1. Bring the -1 down, subtract 1. And 7's a constant. Derivative of sine. We have the unit circle. Any point on the unit circle relates to the trig identities of it. The x values represent the cosine, and the y values represent the sine. So at this point here, it's an x value, so it's a cosine value. This is the y value, so it's sine. This is negative cosine. And this would be negative sine. Right? Because this value here is 1, 0. This is 0, 1. This is -1, 0. This is 0, -1. So far, so good? So this unit circle helps us. Since that's a 0 on the x, we just have a sine value there. If you go this way, those are your derivatives. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of negative sine is negative cosine, and so on and so forth. So going this way, going clockwise, is derivatives. Going counterclockwise are the integrals. So the integral of sine is negative cosine. The integral of negative cosine is negative sine. See, that should help a lot of times when you do this stuff. So that's a come. The derivative of sine is cosine. What's that? Yeah. The trig functions always have, yeah, they're always based, everything on x, y on unit circle is based on x and y, which is cosine and sine. And it always repeats itself. Well, remember, because the sine and cosine functions are infinite repeating, they always keep on going that same pattern. So yeah, that's why it just keeps on going. So remember, this is also 0, or it's at, well, it's 0, but this is at 90 degrees or pi over 2. This way is at pi or 180 degrees. This is at 2 pi or pi over. This is pi over 2, 2 pi over 2, 3 pi over 2, or 270 degrees. This is 0 or 360 degrees or 2 pi. Again, all of these relate the same way, if you're given in degrees or the angles. Yes. If you go counterclockwise, then it's integrals, antiderivative. If y equals 6x cosine x, find y prime. This will be our last one because we're running out of time. So what method we're going to use here? Yeah, power rule, but what else? You can't do it separately. They're connected by what? By multiplication. So it's a product rule. And part of the product rule will be the power rule. So what we have here is F times G. F is x to the 6. G is cosine. The derivative of F is 6x to the 5th. The derivative of cosine is what? Negative sine. Very good. Again, always start with G and do the fishy thingy. Since it's a product, we add. So we have cosine of x times 6x to the 5th plus x to the 6th times negative sine x. Six x to the 5th cosine x minus x to the 6th sine x. As far as we can go. Since it didn't give us anything else to work with. Any questions? Let's do this one too, while we're here. And then we'll call it a day. Sin x plus cosine x. Sin x minus cosine x. Find y prime. Get it? What'd you get?
Huh?
What, how'd you find it?
And it- like vector, we can vector like
You mean it's already factored. You can FOIL it. Okay. You multiply them together. Yeah, it's already in factored form. It's in linear form. Yes, if you did that, if you multiply these two together, sine squared minus sine x cosine x plus sine x cosine x minus cosine squared x. The middle terms cancel. Okay, so if you did that, what's the derivative of sine squared x? Right. This is y. So y prime equals 2 sine x times cosine x. So that means negative cosine squared x would be negative 2 cosine x. Cosine is negative sine x. So it would be positive 2 cosine x sine x. Then we get 0.
plus
Oh, no, should be plus. I put the negative here for it. I shouldn't have put that there. It would be plus. Yeah, so it'd be 4 sine x cosine x. Right. I used negative sign. That should have stayed there, not here. I said I have a whole bunch of these. I mean, I have everything to give y'all. Everything from trigonometry. I have calculus ones here. A whole bunch of trig ones. I have calculus one or somewhere. Oh, this is a differential one. Then integrals here. Derivatives here. So yeah, I'll get these to you next time. I'll put them. Yeah, you want me to send it to you as a reminder or put it on online? Online? Okay, I'll upload these on the where I put the videos and stuff. Okay, then we'll call it a day here. We'll finish this up next time, and then next week we'll start